we're looking at the trigonometric ratios. And we talk about the trigonometric ratios of a right triangle, where typically the hypotenuse is this long side, we call it C. We have, we have a triangle ABC. And the angle, the side opposite the angle is little a. Okay? The side opposite big angle B is little b. It's adjacent to A. And the side opposite of angle C, which is our right angle, is the hypotenuse little c. Now, we have some trigonometric ratios based on the hypotenuse, opposite side of a particular angle, and adjacent side. So here for angle A, the opposite side is little a, the adjacent side is little b. Adjacent means right next to it. So we have 6 basic trigonometric functions. Sine, and we're looking at the angle A here, okay? So sine of A is the side opposite A over the hypotenuse. So that'd be like A over C. And we'll go ahead and rewrite this because we have a shortcut notation. For this, we would normally say sine, S-I-N, A is the side opposite A. This is little a over the hypotenuse of C. Then we have cosine, abbreviate COS of A. That's the side adjacent to A, which is little b, over the hypotenuse, which is C. Then we have tangent. We abbreviate that TAN of A. Then it's going to be opposite, which is A, over adjacent, which is B. Now notice, we're looking at angle A, but we could very well look at angle B or angle C and still find opposite, adjacent, and all that stuff. Now, cotangent of A is a reciprocal function of tangent. It's adjacent over opposite, which is B over A. Secant, we abbreviate SEC of the angle A. It's the hypotenuse over the adjacent, which is the opposite or the reciprocal function of cosine. Hypotenuse over adjacent. And then the last one that we have is cosecant. It's abbreviated CSCA, and it is the reciprocal function of the side. It's hypotenuse over the opposite side, C over A. Okay? So, we could definitely, look at angle B or angle C to get those trigonometric ratios. So what we're going to do now is we are going to look at this triangle that's given to us, and we're going to find some of these trigonometric ratios. They want us to find cosine A, sine B, and cotangent A. So this is our angle A, and that's what we're going to look at for cosine and cotangent. Okay, this is the opposite. Remember, cosine is defined to be adjacent over hypotenuse. So we look at this A. The side that's adjacent to it is 40. The hypotenuse is 41. Okay, so that is cosine A. Sine B, we look here. Remember, sine is opposite over hypotenuse. So this is B. The opposite side is 40. The hypotenuse is 41. So we got the same value back, but notice we looked at 2 different angles. Cotangent is adjacent over opposite. And we're looking at cotangent of A, so adjacent is 40, opposite is 9. So you really have to learn the meanings of these trigonometric ratios. Okay. Another problem, they want us to find the trigonometric ratios of this in the figure. And we're looking at cosecant A, sine B, and cotangent B. Well, what is cosecant? Cosecant is hypotenuse over opposite. Now, what angle are we looking at? We're looking at the angle A. So the hypotenuse is 2. The side opposite A is 1. So cosecant of A is 2. We're looking at sine over B. Sine is opposite over hypotenuse. So this is B. Opposite is the square root of 3 over hypotenuse of 2. So square root of 3 over 2. Then we're looking at cotangent of B. Cotangent is adjacent over opposite. Now we're looking at the angle B. The adjacent side is 1. And the opposite side is the square root of 3. Okay? So as I said, these are things that you're going to have to commit to memory. These trigonometric ratios. Okay. Another one, we're going to look at sine of the angle B, secant of the angle A, and cotangent of the angle B. Remember that sine is opposite over hypotenuse. We're looking at our angle B. The opposite side is 2.47. The hypotenuse is 3.96. And if you take that quotient, you get 0.62. 0.62. Secant of A is hypotenuse over adjacent. So I go to my angle A. The hypotenuse is 3.96. The side next to or touching adjacent to A is 2.47. So that my secant A is 1.60. Then I'm looking at cotangent B. It's adjacent over opposite. So if I look at B, the adjacent side, we don't have the adjacent side, but we do have the opposite side. Now notice, here we are missing one of our legs. We're missing little side A. And in order for us to find that, we're going to go back to what we learned in a previous section, and we're going to use the Pythagorean theorem. Remember that the Pythagorean theorem is A squared plus B squared equals C squared, where C is the hypotenuse. So A is going to be the square root of C squared minus B squared. So A is going to be the square root of 3.96 squared minus 2.47 squared. And when you find what that value is on your calculator, it should be 3.10. And so now we can take that ratio to find cotangent. It's 1.26. So sometimes it's critical for you to find one of the legs or the hypotenuse of that triangle. Let's look at another problem. Here they say A is 8, C is 17, and from this they want us to find cosine of A and cosecant of B. Well, let's go ahead and let's find little b. Remember, b is the square root of c squared minus a squared. Which is 17 squared minus 8 squared. So b is going to be 15. So we're looking at cosine A. Remember, cosine is adjacent over hypotenuse. So we look at our A, adjacent is 15, hypotenuse is 17. And then we want to look at cosecant of B. Remember, cosecant is hypotenuse over opposite. So this is B, so that's hypotenuse, opposite is 17 over 15. And we noted before that cosine and no, these are not reciprocal functions. It just so happened that we got those values back, but they're not reciprocal functions. All right, number 16. Number 16. Here, we are not given a picture. Well, we are given a picture, but you can draw your own picture here. The picture that we're going to use, we'll just stay true to what we had before, where this is angle A, B, C, side A, side C, side B. So in number 16, they tell us A is 9, C is 25. Find sine of A and secant of B. Remember, sine is opposite over hypotenuse. So we're looking at angle A. The opposite is 9. The hypotenuse is 25. And then want to find secant of B. Secant is hypotenuse over adjacent. And we're looking at the angle B. Hypotenuse is 25. The adjacent side is 9. So for this one, we didn't even need to know side B. It was not necessary for us to know what sine B was. Let's look at another problem. Again, same triangle setup. A, B, C, A, B, C. It says if A is 67 and B is 119, we need to find cosine of big A and cotangent of B. Remember, cosine is adjacent over hypotenuse, and cotangent is adjacent over opposite. So we can see for angle A, adjacent is 119 over hypotenuse. We don't know the hypotenuse, but we can definitely find it. It's the square root of A squared plus B squared. So it's a square root of 119 squared, or 67 is A. It really doesn't matter the order here when you are adding. The order matters when you're subtracting. 67 squared plus 119 squared. So C is going to be, the square root's a large number, 18,650. So this is 119 over the square root of 18,650. And then we go to cotangent B, it's adjacent, which is 67 over opposite, 119. All right, let's look at number 22. Again, let's draw a triangle. A, B, C, little c, little b, little a. So A is 3.44. C is 6.82. And B, let's go ahead and find it. It is C squared minus 3.44 squared. 5.89 when you put that in your calculator. So now we can look at cotangent of A. It's adjacent over opposite. So this is our angle A. Adjacent is at 5.89 over opposite 3.44. So we get a quotient of 1.71. And then cosecant B. Cosecant is hypotenuse over opposite. We're looking at B. So hypotenuse is 6.82 over the opposite side of 5. That should be 89. And that quotient is 1.16. 1.16. All right, number 26. It says in the exercises 25 to 36, use the given trigonometric ratios to find the indicated trigonometric ratios. Okay, so we are given that sine A is 1 over 2. And remember that sine represents opposite over hypotenuse. So if this is A, then the opposite side is 1, the hypotenuse is 2. To find cosine A, cosine is adjacent over hypotenuse. We know our hypotenuse is 2, and we define this adjacent side. And we define little b. So remember, b is the square root of our hypotenuse squared minus the other leg squared. B is the square root of 3. So cosine of A is the square root of 3 over 2. Square root of 3 over 2. All right, number 30. If we know that cosecant A is 2.64, we can call that 2.64 over 1. And cosecant is hypotenuse over opposite. So we can draw our triangle. This is our angle A, little a. We have our hypotenuse, 2.64. The opposite side is 1. We need to find tangent A, which is opposite over adjacent. So the opposite is 1. What is the adjacent? This B. Well, B is the square root of the hypotenuse squared minus that leg squared. So B is 2.44. So tangent A is 1 over 2.44.